The sky at night looks sparse. A few hundred stars, depending on where you are. A lot of black between them. It gives the impression of a mostly empty place. The universe is full, though. That's the part the looking doesn't carry. 2 trillion galaxies is the current estimate, and that number is large enough that it stops working as a number. Each of those galaxies holds hundreds of billions of stars. Most of those stars have planets. Across all of that, right now, things are happening. Light is being emitted. Matter is moving. Physical processes are underway on scales that the word vast doesn't really touch. The universe isn't sparse. It's dense, continuously active, full in every direction at once. The sky looks the way it does from here because of what here means. There is light that left certain galaxies a very long time ago. It has been traveling since then, at the speed light travels, through open space with nothing in the way. That light is somewhere between there and here, right now, in transit, covering distance the way light always does, and it will never arrive. The journey is real. The light is moving. The arrival simply isn't coming, and the amount of time that passes doesn't change that. These aren't a few unusual galaxies at the edge of what telescopes can barely detect. The majority of what exists is somewhere that has no connection to here. No signal from there will ever land here, and nothing from here will ever reach there. Those galaxies are real, active, full of whatever is physically underway in them at this moment. The night sky just carries none of it. There's probably some quiet in the room right now, the kind that makes the ceiling visible. The sky outside holds light from a portion of what exists. Most of what exists is somewhere from which no light has ever completed the crossing. And the reason for that is something worth following slowly, because it doesn't come from anything obvious. Something happens to light crossing very large distances. That doesn't happen at smaller ones. It leaves its source correctly. It moves forward continuously, gaining ground every second, and the distance it still needs to cover keeps increasing while it travels. The light is moving, the gap is growing, both things true at the same time. After a year of travel, the destination is further away than when the journey started. That's the thing that needs sitting with for a moment, because it doesn't match anything in ordinary experience. Normally, something moving toward a destination reduces the remaining distance. Always. That's what moving toward something means. But at large enough scales that stops being true. And the reason is something about what space actually is. The ordinary picture of space is something like a fixed room, stable with things scattered through it. Distance is just a measurement of how much room sits between 2 points, and light crosses that room at a fixed rate. Given enough time, the gap closes. That picture holds well enough for everything, an ordinary experience, and for enormous distances. Stars, nearby galaxies, most of what a telescope can detect. It holds until a certain scale, and then quietly it doesn't. Space isn't fixed. It stretches continuously, in every direction, everywhere, at once. The galaxies themselves stay roughly where they are, relative to their immediate surroundings. The space between them grows. The distance between 2 points increases, because the medium itself is getting larger. The way the surface of something expanding carries points further apart, without either point moving across it. At small scales, this is invisible. Gravity holds things together easily, and the expansion doesn't register. But across very large distances, it accumulates. The further apart 2 points are, the more space sits between them, and the more that space stretches per moment. A way to feel this: a long elastic bandwidth, 2 points on it, stretching slowly and continuously. A small ant walking from one point toward the other moves at a fixed pace. If the band stretches slowly enough, the ant gains more ground than it loses, and eventually arrives. But if the band stretches fast enough, the destination moves away faster than the ant's walking closes the gap. The ant is moving the whole time. It isn't blocked. There's just more distance being added than it can cover. That's what happens to light beyond a certain distance. The space between here and those galaxies is expanding fast enough that the light moving continuously forward cannot reduce the remaining gap. The destination keeps receding. More distance appears between the light and where it's going than the light can cross, which means there's a threshold, a specific distance in every direction, beyond which light from a source will never arrive here. A galaxy just beyond that distance could emit light continuously for the entire remaining life of the universe, and none of it would complete the crossing. That threshold has a name: the cosmic event horizon, though what it is physically matters more than what it's called. It's the distance at which space between 2 points expands faster than light moves through it. What's harder to absorb is where that threshold sits. Because the universe has been expanding for a very long time, it doesn't sit at some extreme edge that only the most powerful telescopes approach. The majority of galaxies are already beyond it. Most of what exists is already somewhere from which nothing will ever arrive here. The sky looks sparse, but the universe on the other side of that threshold is full, active, emitting. Physically underway right now, the crossing just can't complete. And there's more to what that means than the light that doesn't arrive, because the disconnection runs in both directions, and it affects more than what can be seen. There is light that left a galaxy a very long time ago. It left correctly at the speed light travels, in the right direction, through open space. Nothing was blocking it when it left. Nothing has blocked it since. It has been moving continuously, covering real distance every second, for longer than the Earth has existed. And the distance between that light and here is larger now than it was when the light departed. That takes a moment. The light has been traveling toward here for billions of years, and is further away now than when it started. Not because it slowed down, not because it turned, because the space it needs to cross has been expanding the entire time it's been crossing it, and expanding faster than the light can travel through it. Every second, the light gains some ground. Every second, the expansion adds more ground than the light gained. The gap widens, continuously, quietly, for the entire duration of the journey. The light doesn't know this, in whatever sense light can be said to know anything. It just moves forward. It will keep moving forward. It will never arrive. What's strange is that this same galaxy, earlier in its history, sent light that will arrive here. That older light left when the universe was younger and smaller, when the distance between here and there was short enough, that the expansion hadn't yet accumulated past what light could compensate for. That light has been traveling for billions of years and will eventually land here. Someone or something will detect it. But light leaving that same galaxy now today, at this moment, will not arrive. The universe has expanded enough in the intervening time that the threshold has moved. The same source, the same direction, the same empty space. The new light departs into conditions that have changed, and those conditions mean the crossing is no longer completable. Two signals from the same place, one old enough to still belong to a connected universe, one new enough to belong to a disconnected one, both moving at exactly the same speed, through space that looks identical. The difference between them is only when they left, and what the universe had quietly become by then. It's worth staying with the older light for a moment, the light that will arrive. That light has been in transit for most of the universe's history. While it was traveling, galaxies formed. Stars lived and ended. This solar system appeared. Everything that has ever happened here happened while that light was somewhere between there and here, crossing a distance that kept changing around it. At some points in its journey, the expansion was working against it significantly. At others, as it got closer, the local expansion rate mattered less, and the light began genuinely gaining on the destination. It will arrive, having crossed a universe that was a different size when the journey started than it is now. The light that left today won't have that. It starts its journey in a universe that has already expanded past the point where the crossing is possible. From its first moment of travel, it is falling behind. The gap is widening, and it will keep widening for the rest of time, with the light always moving forward and the destination always further away, not by a little and not slowing down. Somewhere out there, at this moment, there is a point in space where that light is. A specific location, moving forward at the speed light moves. It's real. It occupies a position, and there is no future in which that position and here are the same position. The room is quiet enough that this kind of thing can settle without needing to be resolved immediately. That light will travel for the rest of the universe's life. It will cross distances that are genuinely enormous by any ordinary measure. And the gap between it and here will be larger at the end of the universe than it is right now. The journey doesn't stall. It doesn't end. It just continues in a direction that never closes. There's an assumption built into sending a message, that it arrives, and that if it arrives, something comes back. The idea of sending and receiving is so paired in ordinary experience that the time between them feels like waiting. Something is in transit, crossing a distance, and eventually the crossing completes. The wait has an object. Something is on its way. A signal leaves here toward a galaxy far enough away. It departs correctly at the speed light travels in the right direction through open space. In the first moments after departure, it is covering real distance every second, moving through space that looks the same as the space around any other signal ever sent. Nothing distinguishes this journey from a shorter one, at least not yet. Time passes. The signal continues forward. The distance between it and its destination is, at this point, still very large, but the signal is moving, so that distance is reducing. That's what the signal is doing. That's what it will keep doing. More time passes, a year, 1,000 years. The signal has covered an enormous distance by any ordinary measure, further than any probe humanity has ever launched, further than light travels in recorded history. It is still moving, still covering real distance every second, still heading in the right direction through open space. And the galaxy it's heading toward is further away than when the signal departed. The signal hasn't slowed. Nothing has interrupted it. The space ahead of it is open, but the space between the signal and its destination has been expanding the entire time. Quietly, continuously, everywhere at once. And that expansion has been adding distance faster than the signal has been removing it. The gap between the signal and where it's going has been widening from the first moment of the journey. And it is wider now than it was then. And it will be wider still after another 1,000 years of travel. The signal continues forward. Time continues passing. The gap continues widening. From the galaxy on the other side, the situation looks the same in reverse. Whatever light or signal that galaxy has emitted in this direction has been traveling for a very long time through open space, at the right speed, covering real distance every second. And the distance between that signal and here has been increasing the whole time. That signal is somewhere out there right now, in a specific location, moving forward. The distance between it and here is larger than it was a year ago. Both signals are in transit simultaneously. Both are moving forward. Both are in expanding space that is adding distance faster than they can cross it. There are galaxies near the edge of this threshold that are still sending light that arrives here. That light completes the crossing, but the journey changes it. The expansion it crossed has been stretching the light waves during transit, lengthening them, shifting them toward the red end of the spectrum, making them longer and lower in energy than when they departed. A signal that left as visible light might arrive shifted so far that only instruments sensitive to wavelengths the eye can't perceive would detect it at all. The light arrives, but bearing the full record of what it crossed to get here, stretched by the expansion it moved through, carrying the distance in its wavelength. Further out, the stretching becomes total. The light is shifted beyond detection, and further out still, the light is in the same condition as that signal, traveling forward. The gap widening, the crossing not completing. There's a specific quality to what this means for the galaxy on the other side. From there, this region of the universe is in the same position. The light from here, from this galaxy, from this general location, all of it is on the wrong side of their threshold. A civilization in that galaxy, looking in this direction, would be looking into a region from which nothing arrives. Not a dark region, not an empty one. A region that is, from their instruments and their waiting, simply absent. Whatever is happening here, the sun, the stars, whatever physical processes are underway in this part of the universe is happening somewhere that has no path to their detectors. They are waiting, in whatever sense waiting applies, for signals that are in the same condition as the ones sent from here, toward them traveling forward, the gap widening, time passing, nothing arriving. The room, wherever this is being heard, is probably quiet enough that the outside feels far away. That kind of quiet where something can travel a long way without landing anywhere. A telescope points outward and waits. That's mostly what it does. Wait for light to arrive. Whatever it shows has already completed a journey. Light that departed somewhere and crossed a distance, and finally landed on the detector. The further the source, the longer that crossing took. A galaxy in the record isn't the galaxy as it is now. It's the galaxy as it was when that particular light left, which might be hundreds of millions of years ago, or billions. The telescope isn't looking outward. It's looking backward, into the record of what has already arrived. The record keeps growing. New light arrives continuously from sources in every direction, and the instruments keep receiving it and adding it to the picture of what exists out there. Each arrival is the conclusion of a very long journey. Light that spent an enormous amount of time crossing an enormous distance, and finally reached here. At a certain distance, the arrivals thin out. The light coming from the furthest detectable sources is old, among the oldest light in the universe, emitted when everything was much closer together, and the expansion hadn't yet accumulated past what light could compensate for. That light arrives, stretched, shifted, far from its original wavelength, barely carrying the shape of what emitted it, but it keeps arriving. The record keeps receiving it. Further out, beyond a certain distance, new arrivals simply stop appearing. The instruments keep waiting. The telescope keeps pointing. Out there, in those directions, galaxies are going about whatever they are doing right now. Stars completing their cycles. Matter moving. Light being emitted in every direction, including this one. That light is somewhere between there and here. Right now, it left its source. It's moving forward through open space. In the distance between it and here is a little larger than it was a moment ago, and a little larger than that now. The instruments keep receiving light from other directions, from sources close enough that the crossing completes. But from those furthest regions, the most recent arrivals are already old light that departed long ago, from a universe that was smaller and more connected than this one. The galaxy that emitted it has continued existing since then, has continued emitting whatever light it has sent more recently is out there somewhere in transit, and the gap between it and here is wider now than when it departed. At some point, the arrivals from a given galaxy space out. The light coming from it now is old. The newer light, more recent emissions from the same source, is somewhere in the expanding gap. The telescope keeps receiving the old light for a while, the tail end of what departed early enough to still be completing the crossing. And then the arrivals from that particular direction simply don't resume. The galaxy is still there, still emitting. The instruments just stop receiving anything new from it. Each era of observers inherits a slightly different sky than the one before. The light that arrives tonight includes some of the last emissions from galaxies near the edge of the reachable region. Light that departed recently, enough to still complete the crossing, but only just. Future instruments, more sensitive than anything that exists now, will find that some of those sources have gone quiet. The arrivals stopped. Whatever those galaxies have been doing since the last detectable light departed, the record here simply doesn't include it. The sky outside right now is receiving light from an enormous number of sources. Each piece of light arriving at this moment left its source at a different time, from a different distance, and has been crossing a universe that was a different size when each journey began. Some of it left before this solar system existed. Some of it left recently enough that the source has barely changed since departure. And beyond all of it, in every direction, the instruments keep pointing into regions from which nothing new seems to be arriving. Not because those regions have gone quiet, because the arrivals stopped completing the crossing. Somewhere out there in the expanding gap, and the instruments keep waiting. And the gap keeps widening. And the sky in those directions holds only what already arrived. The telescope doesn't know this. It just keeps receiving whatever comes. The universe is full. That's the part that keeps being easy to forget, because the sky doesn't show it. A few hundred visible stars. On a clear night, plenty of dark between them, and the impression settles in quietly. A sparse place, mostly empty, with occasional bright points scattered through a lot of nothing. But the darkness between those points isn't absence. It's full of galaxies, full of stars, full of light being emitted right now in every direction. The universe isn't sparse. The sky just receives a fraction of what's out there. The fraction it receives is everything that has completed the crossing. Light that departed from close enough, early enough, that the expanding space between here and there didn't accumulate past what the light could compensate for. That light arrives, old, in some cases, from sources that looked different when it departed, and the instruments receive it, and the eye sees it, and it becomes part of the picture of what exists. The sky is built from arrivals, from crossings that completed Everything else is still out there. The galaxies beyond the threshold are doing what galaxies do. Stars are completing their cycles. Matter is moving. Light is being emitted in every direction, including this one, continuously. Some of that light is in transit right now, somewhere between there and here, moving forward through open space, covering real distance every second. The space it's crossing is expanding. The distance ahead of it is growing. The light keeps moving, and the gap keeps widening, and the instruments here keep receiving other light from other directions, and nothing from those regions ever joins the arrivals. It has been this way for a long time. The threshold isn't new. The majority of galaxies crossed it long ago, as the expansion accumulated over billions of years. Whatever those galaxies have been doing since their last detectable light departed, and they have been doing things, the physical processes didn't stop, belongs to a part of the universe's history that the record here simply doesn't include. The arrivals from those directions stopped. The gap is wider now than when they stopped. The instruments keep pointing. The sky keeps receiving what arrives. In certain directions, nothing new has come in a very long time. And whatever is out there in those directions has been continuing without any connection to here. Not waiting, not signaling, just continuing. The way physical processes continue, indifferent to whether anything on the other side of the threshold is receiving news of them. There's something almost ordinary about it. Once the scale settles, space expands. Past a certain distance, it expands faster than light moves. The light from beyond that distance doesn't complete the crossing. The universe on the other side of that distance is full and active and completely unreachable from here, in both directions, regardless of how long the instruments wait. Somewhere outside right now, the sky holds everything that has managed to arrive. It's a lot. More than any observation has fully catalogued. More than the eye can distinguish on the clearest night. And surrounding all of it, in every direction, is most of what exists, still emitting, still full. The light from it somewhere in the expanding gap between there and here. The room is quiet. The sky outside is receiving arrivals. Most of the universe is somewhere else entirely, continuing. The sky at night looks sparse. A few hundred visible stars, plenty of dark between them. The impression of a mostly empty place, occasional bright points scattered through a lot of nothing. That impression is easy to keep because nothing about the looking contradicts it. The sky presents itself as sparse, and the eye accepts that. The universe is full, though. That's the part the looking doesn't carry. 2 trillion galaxies is the current estimate, and that number stopped functioning as a number some time ago. Each of those galaxies holds hundreds of billions of stars. Across all of that, right now, things are happening. Light is being emitted. Matter is moving. Physical processes are underway on scales that don't reduce to anything familiar. The universe isn't sparse. It's dense with structure in every direction, continuously active, and has been for most of its existence. The sky looks the way it does from here because of what here means. Space expands. It has been expanding for a very long time, and it continues now. At large enough distances, that expansion adds distance between 2 points faster than light can cross it. A beam of light, traveling through that region, moves forward continuously, covers real ground every second, and the remaining distance keeps growing. The journey continues. The arrival doesn't come. That condition exists in every direction from any given point in the universe. past a certain distance, the crossing doesn't complete, not because anything blocks it, but because the space being crossed keeps producing more of itself faster than any crossing can compensate. And because the universe has been expanding long enough, that distance now sits closer than most of what exists. The majority of galaxies are already beyond it. Whatever they're emitting right now is somewhere in the expanding gap between there and here. Moving forward, the destination receding, the journey without a conclusion. The sky outside shows what's on this side of that threshold. Real light from real sources arriving continuously, some of it having traveled for most of the universe's existence to get here. The arrivals are genuine. The picture they build is genuine. It's just the picture of a portion, the connected portion, the part of the universe that has a physical relationship to here, that can send something that completes the crossing. It's a large portion, more than any catalog has fully counted, large enough to spend a lifetime inside without approaching its edges. And surrounding all of it, in every direction, is most of what exists. Galaxies doing what galaxies do. Stars completing their cycles. Light being emitted continuously, some of it already in transit through the expanding gap. Moving forward, falling behind, the crossing not completing. Whatever is happening out there is happening regardless, indifferent to whether any instrument on this side of the threshold is pointed in that direction. The universe doesn't need to be received to continue. Wherever this is being heard, the room is somewhere inside that connected portion. Inside the fraction of the universe where distances are small enough that crossings complete, where light from a lamp reaches the wall, where sound from outside arrives a moment after it started, where the small physical connections that ordinary experience relies on hold without adjustment. That fraction is where everything familiar happens. It's where the waiting resolves and the signals land and the gap closes. Most of what exists is somewhere that works differently. Not dramatically differently. The same physical laws, the same expansion, the same light moving at the same speed, through the same open space, just past the distance where the expansion tips past what the light can do, and the crossing stops completing, and the arrivals thin out and stop, and whatever continues out there continues without any connection to here. The sky outside is still receiving arrivals. Light that completed the crossing, old light. Some of it carrying the record of sources that looked different when it departed. The arrivals continue the way they have for as long as anything here has been capable of receiving them. The sky looks sparse. The universe isn't. Most of it is somewhere else, continuing.